Welcome back to the series of lectures on microprocessor, microcontroller, and myself Rajakishore, Assistant Professor, Department of ECE, Mari Lakshman Reddy Institute of Technology and Management. So in the last videos, we were discussed about the architecture of 8086 and address different addressing modes of 8086 and the introduction to 8086. In this video, we're going to be discuss about the 8086 pin configuration or a signal description of 8086. So mainly 8086 is available in 40 pin dual inline package. So when I'm saying it is having a 40 pin, so these 40 pins are mainly categorized as three groups. Why these three groups? In the sense, because we know that our 8086 processor is capable to work under a two different modes of operation, like a minimum mode and the maximum mode. So in the pin description or a pin categorized, they have provided separately a group of pins for to make 8086 to operate either in a minimum mode or a maximum mode of configuration. So based on that, our 8086 as categorized as a three groups. One is a common signals. These common signals is nothing but these of the signals, or these are the pins which are common in both a minimum mode and a maximum mode. And the second type of it is a minimum mode signals, and third one is a maximum mode signals. Let us go into the details and of these pin configurations of 8086. So if you see, this is a overall architecture of 8086 pin configuration. So where, as I said, that it is working is in a dual inline package. So the 20 pins 1 to 20 is arranged in one line, and 21 to 40 is arranged in another line. So this type of arrangement we call it as a dual inline configuration or a dual inline package. So now we'll go for individual pin explanation. So in this common mode signals, the pin number 16 to pin number 39 is used for address come data lines, which means that these particular pins are multiplexed. What you mean by multiplex? Which means that that can be either work as an address pin or a data pin. So this pin number AD0 to AD15, that is pin number 16 to 39 reverse or decremental order is used, because as we know that we have a 16-bit data bus. So D0 to D15 is a 16-bit data bus. So as you see that lower order address bus are multiplexed with data bus. So when AD line are used to transmit a memory address, the symbol A is used, which means that if that particular bus is using for a communication between a memory or an IO device to transfer the data, to transfer the address location, we will call those pins as a A0 to A15. If the same pin is used to transmit an address, then we'll call it as a D0 to D15. Again, these pins, again D0 to D15, again subdivided as a 8-bit data bus also, D0 to D7 and D8 to D15. So why we are dividing like this means when I want to use any 8-bit data transmission. So this facility is provided here. So next, if I tell about uh, other pins, that is, so if I tell about the pin number 38 to 35 decrement order, this is combined with A16 by S3, A17 by S4, A18 by S5 and A19 by S6. So which is nothing but it is high order address bus is multiplexed with some status signals. That we discuss the later what is those status signals and how to do it. So again it is these pins are multiplexed with some other status lines. Then if you come for pin number 34, that is called as a BHE bar slash S7. Again it is a multiplex signal where the BHE is nothing but a bus high enable. This is used to enable the data on the most significant half of the data bus, that is D8 to D15. 8-bit device is connected to upper half of the data bus use BHE signal, and this BHE signal is an active low signal and it is multiplexed with your status signal S7. So which means that whenever this pin goes slow, indicating that our data bus, that is to higher order data bus D8 to D15, is transmitting some data. Otherwise, it is working to produce or it working to do some status operation. So when you come for the pin number 33, it is called as a MN/MX bar, which is nothing but this particular pin indicating that whether my processor is working as a minimum mode or a maximum mode configuration. So whenever this particular pin goes to connected to ground pin, when this 33 is connected to ground, which means that my 8086 processor working under a maximum mode configuration. If the same pin is connected to the plus VCC, then we can say that it is operating in minimum mode configuration. Okay, and then one more common signal is called pin number 32, which is nothing but an active low signal. It is a read bar signal, which means that whenever processor is reading some data, so this particular pin going to be used. So when this particular pin is 0, which means that processor is reading some data from memory locations or an IO locations. Again, it is a active low signal. So again, pin number 31 to 24 is again we call the multiplex pins. We'll discuss later, and then we'll go for the another common mode signal. Okay, test. Okay, this particular test is an input tested by the wait instruction, which means that whenever the processor is connected to any external device which is lower than the processor, so at the time that particular slow associated device need to be synchronized. If it is not synchronized, so there is no communication between the processor or any IO devices which is connected. For example, if you take a printer, so printer is a serial communication device. When the processor is send the parallel data, it is not to be synchronized. In such situations, that particular output devices or an input device which sends some signal called as a wait signal, so that has to be raised through this test bar signal. So whenever 8086 will enter into the wait state after executing a wait instruction, and will be resumed execute only when the test bar signal is made low by an active hardware, because it is an active low signal. When it is connected to that particular slow associated hardware, whenever this is slow, then only that. This is used to synchronize an external activity to the processor to an internal operation. So then one more signal is called pin number 22, which is set as a ready signal. This is an acknowledgement from a slow devices or a memory that they have to be completed that particular data transmission. This signal made available by the device is synchronized by 8284A. It is a clock generator to provide a ready input to a 80, which indicates that this pin should be connected to some other an IC called as an 8284 as a clock generator IC, which provides the necessary clock signals for the 8086 processor to test whether this particular devices is connected or not. Again, it is an active high signal, which means that whenever this signal goes high, then it indicates that corresponding operation. So then finally the pin number 21 is a reset pin. So it causes the processor to immediate terminate the present activity. The signal must be active high for the last 4 cycles. Okay, least 4 cycles. So which means that whenever if I want to send any one high input to a pin number 21, which indicating that I want to be reset my 8086. So whenever I'm resetting, whatever the present task carried out by 8086 will be terminate, and all the internal registers and the segment registers, instruction pointer and the program counters are resetted to their respective original positions. Because which means that reset in the sense they won't go to the zero starting condition 000. So some of the registers may start from 00, but stack pointer and other segment registers will have their initial address locations. So whenever this particular pin is active high, then all the registers and segment registers will go to that particular state. Then a clock signal. Okay, the clock signal is nothing but, because as we said that in the previous classes, 8086 can be work under a diff 3 different clock frequencies, and that 8086 work under 5 megahertz clock frequency, 80861 is work under 10 megahertz clock frequency, and 80862 is work under 8 megahertz of. So this is nothing but for 8086 it is required to be connect an external clock generator to provide the necessary internal clock cycles, or the T cycles or the mission cycles. If processor want to be generate, the external clock signal need to be connected through the pin number 19. And one more pin is a common pin called pin number 18 is called as a INTR. Okay, is nothing but an interrupt. This is an interrupt pin. This is a triggered input. This is sampled during the last clock cycle of each instruction to determine the availability of the request. If any interrupt request is pending, the processor enters that interrupt acknowledgement cycle. This signal is again an active high signal and internally synchronized. So again, this particular pin, simple words we can say that it is one of an interrupt signal. If any interrupt is raised through this pin number 18, will gives a least priority, so that it will be staying in wait state until the processor need to complete the current execution. Once the processor completes the current execution, as we said that it will enter into the request cycle. It will check whether any interrupt is occurred. If any interrupt occurred, then that execute that interrupt. So similarly, when we come for the next one is called NMI, which is called as a non-maskable interrupt, which means that if any interrupt is raised through this particular pin, which gives an highest priority, which gives us an highest priority. So whenever raised interrupt through pin number 17, which means that the processor goes to be terminate or stops the current execution and goes back to its interrupt request, so that after attempting that particular interrupt, it will come back to its original position, and it will take that continues the corresponding task which is kept by hold in previous. So which means that this particular NMI interrupt raised, okay, is giving has a highest priority. Again, if I want to take a best examples in case of our mobile phones, so mobile phone is meant for to call only. So when I'm watching any video or when I'm chatting to someone, if any call occurs, what is happening? The call is ringing even though I'm watching, because the priority of the mobile phones gives to the calling. So that video will be automatically passed and I need to be attempt that call. So that means that is a type of an interrupt is it. In case if I take a non-priority interrupt like an INTR, so if I'm watching a movie, if any message comes that gives a pop-up, that's all. That is depends upon a user. If he completes that current task and whenever he want to be checked, he going to be checked that particular. So then another signals like a VCC and ground. So the 8086 provides the two different ground signals, like a pin number 1 and pin number 20 is a ground signals, and the plus VCC is nothing but a pin number 40 and it is works under a plus 5 volt supply. Okay, then we'll go for a minimum mode signals. Okay, how we know that whether the 8086 pin number 31 to 24 is provides a minimum mode signals? How the processor knows that? So it knows by using the mn slash mx bar signal. If this particular mn slash mx bar signal is connected to the plus VCC, then it works in the minimum mode configuration. Let's see the minimum mode pins here. So 8086, this is the operation, as I said, that minimum mode of operation. Okay, so pin number 24 to 31 is used for the minimum mode operation, where pin number this 27 is a data transmit receiver. This is a output signal from the processor to control the direction of data flow through the data trans receivers. So then a data enable pin DEN is a 26 pin. It is an output signal from the processor used for an output enable of the receiver. Then ALE is an address latch enable used to demultiplex the address and data lines using an external latch. So using this pin number 25 only, we can able to know that whether that particular address multiplex address come data bus, this particular multiplex address come data bus, whether what type of information is transmitting, whether it is transmitting a data or an address is known by this particular address latch enable signal. And this user to define IO memory access or an IO access for the memory instruction. It is an high and or it is nothing but this MN slash IO bar is a memory slash IO bar. This particular pin indicating that whether the processor is performing that particular task with a memory or an IO devices. And write bar is a signal which used to indicate whether processor is writing information or not. Okay, okay, and then interrupt acknowledgement signal pin number 24 is used to whenever any interrupt like 17 or 18 raises, that can be known by this pin number 21. And the 30 and 31 is the hold acknowledgement pins, which pins are used whenever usually for a DMA operation is performed. In such cases, we are going to be use these particular pins. Then if you come for the maximum mode signals, these are the maximum mode signals where the 28, 27, 26 are the sum of the status signals which tells that which operation is performing. So when it is nothing but maximum mode is nothing but the 8086 handovers all the control data and the address buses to other co-processor like 8087 arithmetic processor. In such scenarios, if I want to know the status of that what arithmetic processor is doing, these are the three signals where 000 is an interrupt acknowledgement, 001 is a read input port, 010 is a writing to the output port, 011 is halt, 100 is a code access, and 111 is a read memory, 110 is a write memory, and 11 is an inactive mode. So these are the different status signals which can be known by checking these three pins in case of a maximum mode configuration. Similarly, whether the data is transmitting a half byte or a full byte can be known by using a queue status signals. Okay, this processor provides the status of queuing those lines. So the queue status can be used by the external device to track the internal status of the queue, because we know that 8086 having a 6 byte of queue. So what that 6 byte of queue is doing? So when no operation is performing by the queue, first byte of opcode is in the queue is empty, and the subsequent data is transmitted. So that is about the queuing status of the pins 25 and 26 giving. Okay, then and the bus request and grant signals are those are used to a local bus whenever I'm handovering the any buses to the co-processor. This particular bus grant signals will be provided, and the lock is an output signal activated whenever the prefix lock is provided. The 8086 output is low on the pin while executing the instruction prefixed by the lock to prevent other bus masters gaining control of a system bus. So These are the different more pins and the configurations. In the little bit more explanatory, you can refer any website or any test books. You can get some more information about this pin configuration. And the next videos we are going to be discuss about the instruction set of 8086. Till then, happy reading. Thank you.